Number 8 is something that's going to make you mad. So throughout this course, I have made a very, very big deal about focusing on units. Let the units be your guide. I've made a big deal about that. You guys are probably pretty tired of it. But here it comes into play very, very directly. Now, when you read number 8, it took 546 seconds for a sample of xenon to effuse. What would the molar mass be of a gas that took in 1 second for the same number of moles to effuse? You might be tempted to use Graham's law in the exact same way that we have been, right? You'd think I'm trying to solve for the molar mass of this unknown, so rate of unknown goes there, and then the rate of what I do know, xenon, is there. You might be tempted to do this exact same thing, plug and chug, in the exact same way that we've been doing this, and that will get you the wrong answer. Instead of getting mad, I want to point out to you why. Now, we're still going to use this equation. Rate of xenon over rate of the unknown is equal to the molar mass of the unknown divided by the molar mass of xenon. We're absolutely going to use that. However, the temptation, which would lead you to the wrong answer, is to plug 546 seconds into your rate for xenon. With that is 546 seconds is not a rate. 546 seconds is a time. Yeah? A rate is, like, for example, like a distance is, like speed is distance per time, meaning time, these two values, are denominator, right? So that rate, which in this case is moles per second, right? Moles per second. Now, the same number of moles, doing the same number of moles for both substances, and so the number of moles actually cancel out. And so what we have here is a 1 over seconds, meaning we have to invert these numbers that we're plugging in, right? Because these are times. Times go on denominators. So whereas your temptation would be to plug, to have, 546 over 301, and then just continue to solve like normal, that'll get you the wrong answer, because you need to actually invert this because it's 1 over seconds. This is a rate. 1 over seconds. This is a time, right? A rate is something per time, per unit time. So because these are pers, these are actually going to be on the denominator. So functionally, I'm going to go 301 seconds over 546 seconds is equal to the molar mass of this unknown divided by the molar mass of xenon, which is 131.29. Check in the periodic table if you don't believe me. I'm going to start solving for this, so I'll square both sides, and so I'll end up with molar mass of the unknown divided by, let's see what the square root of, oh no, I don't have to square root that because it's out of the radical, 131.29, and then let's see what that actually works out to be. 301 divided by 546, and we're going to square that. We end up with 0.03. I'm going to stick with 3 sig figs, so 0.304. Right? And so this is, yeah, what I'm solving, sorry, this is what I'm solving for. So I need to get 131.2 or 0.29 out of there, so multiply both sides by that. And my mass, my molar mass, what did I just do? Times. Why is that? What? There we go. 3 sig figs, we can go to 39.9. Again, focus on the units. Understand the units so that you can understand the numbers and the values that you're given, and so you can make these meaningful statements about, the world.